All right, let's take a look at your Chapter 7 homework. This is problem 1. In problem 1, we're going to be getting into the normal curve. So let's say the normal distribution of a mean is 500. So essentially, if I drew out the curve, they're essentially saying that the mean of 500 would be right in the middle. And they give you that the standard deviation, I'm going to say that sigma is equal to 10. So they want to know, it says about 68% of the observations lie between what two values? Well, by default, by definition, that is a plus 1 or a minus 1 standard deviation. So we always know that by rule. So if we go out down to a -1 standard deviation, all the way up to a +1 standard deviation, and we know 1 standard deviation is equal to 10, it'd be 500 plus 10 and 500 minus 10, and that would give you 490, and then 510 would be the two values. At 95%, we know it's plus or minus 2 standard deviations. So again, if I do my curve, and again, putting 500 in the middle, and again, they want to know at 95%, so a -2 standard deviations, we know that's going to be -20. Any +2 standard deviations, we know that's going to be a +20. And so that's where you're going to get the 520 and the 480. You're just adding and subtracting those from 500. So that would be the second one. Now on the third one, let me move this down. By definition, at 99.7%, we know that's a plus or minus 3 standard deviations. So if I drew my curve, sorry about that, my writing isn't the best. So you're basically saying you got 500 in the middle, and again, 99.7%. So you got a -3 and a +3 standard deviations. So you're going to add 30 and subtract 30, because remember, 3 times 10 is 30. So you're going to get 530 and 470 as your two values. All righty, guys. So that is my comments for problem 1. Let's check out problem 2. And in this one, we're going to be calculating z-values. And so let's get to a z-value calculation. So remember the z-value formula, it's z is equal to x minus mu divided by sigma, where x is your variable, mu is your mean, sigma is your standard deviation. And in this problem, we got a couple of these to calculate. So we've got Rob and Rachel. They are each earning $70,000 a year. Rachel works in retail where the average salary is $55,000. So if we were going to do a z-score for Rachel, we would take the 70,000, compare that to the retail average of 55, and then the standard deviation is 8,000, and you just divide that by 8. And so for Rachel, you would end up with a z-value right around 1.88. For Rob, he's making 70, and the average in engineering is 80. That's the population mean for engineering industry. And then the standard deviation is 5. So in that case, you're going to be getting a negative z-value, and you'd get right at, looks like it's right at a -2 standard deviations. And then they just want you to comment. So Rob is below, and Rachel would be above the mean in their respective industries. All righty, so that would take care of my comments, and there's of course the explanations down there as well as for the calculations that I just showed you. Let's check out number 3. And in this one, we're going to be looking at z, and then we're going to look up the z values to get the area. So I'll show you how to use the normal curve table. So we've got, it says we got a normal mean of 20 and a standard deviation of 4. So I usually like to label this as mu is equal to 20 and sigma is equal to 4. So the idea here is they want the z value associated with 25. So of course you take 25, that's your z value, minus the mean of 20, and then divide that by 4, and you're going to get right at 1.25. Pretty simple. Part B, they want you to figure out the proportion. Remember, when they say proportion, that's also means the area, or we're going to later on refer to that as the probability. They want us to look up between those two numbers. So essentially, if I draw my curve, put this here, and we know that the mean, which is 20, is in the middle, and 25 is what they want us to find. So I draw the picture. If I want to find this area, or proportion right there. First of all, you need to get the z-value. We know by default that's going to be a z-value of 0 because it's in the middle. And we just calculated the z-value for 25. We just said it's 1.25. So we're trying to find the area between a z-value of 0 and 1.25. Well, to do that, we're going to go to our tables. And let me show you the normal curve table. And we're simply going to look up 1.25. So the way you do that here is your z-value is right here. I go down to where I see 1.2, and then I'm looking to see where that intersects with 1.05. So your top row and your left margin, that's your z-values. The areas are all in the middle. So 1.2, and then here's 0.05. So it looks like that's 0.3944. So what that means, I'm trying to illustrate this right here. What that means is that if, that's not a very good picture, sorry about that. If I am trying to find an area between 0 and a z-value of 1.25, the way this curve works is all the areas they give you are to the left of the z-value, all the way down to 0. As you can see up here, they're kind of giving that illustration right there. So this area, which says 0.3944, that essentially is our answer. So remember, this z-value table gives you the area to the left of z, all the way down to the midpoint of the curve. So between 0 and 1.25 is going to be 0.3944. And if I go back to the problem, let me change my screen share. There we are. You can see as that's going to be basically your final answer. Alrighty. Now on part C, they want us to find the proportion that's less than 18. So on that one, let me draw, again, I like to always draw the curve when I work these out. So on that one, if I were to draw my curve, and we know 20 is in the middle, there's 18, draw my line, I'm trying to find the area to the left of 18. So I got to get a z-value, and of course they're going to show you that calculation right here. Z-value of 18 minus 20 over 4. So z-value is a negative 0.5, which just basically means you're less than the mean. And they want to find the area less than that. So the problem is when you go to your table, again, I'll try to illustrate this right here. When you go to your table doesn't give you negative z's. They all give you positive. But because of symmetry, if I know if that's negative 0.5, if I go to my table and look up a positive 0.5, what's going to happen is your table is going to give you that area. That's what your table will give you, because your table will give you from 0 all the way up to a positive 0.5. So all I'm going to have to do is, if I go to my table and look up 0.5, your table is going to give you, and I'll show you in a minute, your table is going to give you 0.1915 as that area. Well, I want to find this area because of symmetry. This area and this area would be the same. So if I take 0.5 and subtract out that 0.1915, that would give me about 0.3085, which, if it's in other words, that would be the area to the right of 0.5, which is the same as the area to the left of a negative 0.5. So that's where they're coming up with that answer. So again, let me just draw that one more time. So again, if I have, just using symmetry, I'll draw my two lines. If I have a negative 0.5 and a positive 0.5, what we're basically saying is these two areas to the left of negative 0.5 and to the right of positive 0.5, those two areas are essentially the same. So again, let me go back. I just want to make sure you know where to go to find that. So again, if I'm in my table and I look up a positive 0.5, that's where the 0 is. That's your area. That's 0.1915. Remember, that's going to give you from 0 up to 0.5 z. That's 0.1915. And I want to the right, because if I can get to the right, that'll be the same as to the left. And that's the concept of symmetry. All right. So that would be my comments on this one. Let me go back. All righty, so that is problem 3. Let's check out problem 4. Now we're just going to be practicing the rest of these. Along the way, we're just going to be practicing calculating z-values and looking up areas. All right, so on the first one, looks like we've got, and I'll kind of go back and forth, and I'll go back to the table in a minute. So let me identify what the numbers are. So we've got, it says the mean hourly pay of American Airlines flight attendants is normally distributed. That's all you need to see. We know it's normal curve. The mean's 29.81. Standard deviation is 9.31. They want the probability that the hourly pay of a randomly selected flight attendant. We got 3 scenarios here. So under this umbrella, what we'll do is, first thing I'll do is I'll identify the mean. So mu is 29.81. Sigma is going to be 9.31. So for this first one, if I drew my curve, remember the mean's in the middle. We want between the mean, which is 29.81, and $35. So we want to find the area right there between 29.81 and $35. So we know the z-value is 0 in the middle. To get the z-value at 35, it's just going to be 35 minus 29.81. Divide that by 9.31. So once you do that, you're going to get right around 0.56 as your z-value. So what you do is you go to your z-table. Draw this again. So you look up a z-value of 0.56. And what's going to happen is, again, your table will give you that area. So if you look up 0.56, which let me show you that, I'll go to there in a minute. So again, in our table, I go down and I find 0.5, and then there's 0.56 because that corresponds with the 0.06. Your answer should be 0.2123. And let's go back. I'll show you that that's what the answer is. You can see that there's your answer, 0.2123. That's essentially how it works. So, all right, so then let's check out part B. And on part B, they want more than 35. So we just calculated that. So again, here we are at the mean, and of course we had $35. They want you to go to the right of the curve, and we already figured out, of course, the z-value is 0.56. And from part A, we figured out that that area was 0.2123. So if I went to the right, all I got to do is take 0.5 minus 0.2123. And of course, that's going to give you your 0.2877. So we just went to the right. Remember, we're just looking at the half curve. So remember, each half is 50-50. So if I know from 0 to 0.56 is 0.2123, if I just subtract that from 0.5, that'll give me the rest of the curve. All right, so then on part C, let me get that out of there so you can see this one. So on part C, they want us to go to less than $20 per hour. So again, if I draw my curve, and we know that 29.81 is in the middle, and they want less than 20, so I'll just say 20 is somewhere down here below the mean. I want to find that. So you got to get a z-value for 20. So remember, it's going to be 20 minus 29.81. Divide that by 9.31. And I usually take the z-value out to 2 decimals. That's going to give us right around 1.05. So you know what to do. So if you go to your table and you look up 1.05, your table is going to give you the area between 0 and a positive. Let me go back. This is actually a negative 1.05. So if that's a negative 1.05, your table will give you the area from 0 up to a positive 1.05. So whatever number you look up in your table, you're going to have to subtract from 0.5 to get your area. So if you look up 1.05 in your table, you're going to get an area that's 0.3531. That would be that area. And again, keep in mind, it's the half probability table. So to get the corresponding area to the right, which is the same as the area to the left, you just have to take 0.05 and subtract out that 0.3531. And of course, that's going to give you the 0.1469. So again, let me just go back for a moment. I'm going to show you again where you find that 1.05. So we got 1.05. This is where they're getting it. That's the number they would have looked up, 0.3531. And remember, that would have been between 0 and positive 1.05. So if I want to go to the right, which is the same as to the left, anytime you're dealing with negatives, you just have to subtract from 0.5. All right, let's go back. And that would be my comments for question 4. Let's check out number 5. Again, we're just practicing the curve. So in number 5, it says we've got a mean of 50 and a standard deviation of 4. And the first one we want to go between 44 and 55. So again, you know what to do. I mean, if I just let me draw my visual here. So remember, mu is equal to 50, sigma is equal to 4. So if I put 50 in the middle, I want to find between, what they say, 44, which would be below the mean, and 55, which is above the mean. So I want to find between those two data points. So that's the area I want. So you got to find both this z, and that's going to, of course, be a negative z, right? So you'd have what, 55 minus 50 over 4, and you'd have 44 minus 50 over 4. Again, that's going to have, that's your first step, is you always got to get your z values. So it looks like you're going to have for 44, it's going to be, it looks like that's going to be a negative 1.5. Let me write this here. So you have a negative 1.5, and then for the 55, you're going to get, it looks like it's 1.25. So in this case, you're looking between two different z values. So if you go to your table and you look up 1.25 in your z table, let me just draw that right there to kind of split this to make sure you know where we're looking. So if I look up 1.25 in your z value table, that's going to give you, it looks like it's right at 0.3944. So what will happen is we know that that area is 0.3944. Let me change the stylus a little bit. Okay. So now, if I go and find my area that's a 1.5, and of course, let me show you again the table. Let me go back. Here's screen 2. All right, so again, just to show you that. So we've got, there's 1.2 and of course 1.05, which would be right there. All right, now, so then if I go, and now I want to look up a 1.25, 1.25 would be, here's 1.2, and 1.25, I meant 1.5, I'm sorry. 1.5, if I look up 1.5, that's going to be an area that's 0.4332. All right, and so if I look at this, and again, let me draw it on this screen, just to show you what we're looking at. Just a second. Okay, I'm back. All right. So in this case, try to draw this a little bit better than last time. All right. So if we've got 0, and then of course we've got a positive 1.25, and then we've got a negative 1.5. So I'm going to draw my area. And just to remind you, that's the area we're going to try to find. And so what we simply do is, in this case, if you go between 0 and a negative 1.5, we've got to find that area. So remember how to do that. So if I look up 1.5, there's your area right there. So between 0 and negative 1.5 is the same as 0 and positive 1.5. I know that that area has to be 0.4332. And then I know that that area has to be 0.3944. So to get the complete area, all you have to do is add these together. And if I add those together, that's going to give us, it looks like it's right at 8.8276. Which is your answer right there, 18276. So again, that's when you're looking at, so the rule of thumb is anytime you're looking between two values, all you do is you look up, in this case, since one's a negative z-value, you have to look up each z-value area individually. And then once you found those areas, in this case, because one was a negative and the other one was a positive, you simply had to add the areas together. If you had two positive z-values, which we'll have up here in a minute, you'll see how you'll have to subtract and not add. Okay, on part B, it looks like they want greater than 55. So again, I like to illustrate these. So again, here is 50. They want greater than 55. So convert 55 into a z-value. So it'd be 55 minus 50. And then of course you would divide that by 4. And that's going to give you, of course, 1.25 as your z-value. But we want to the right, not to the left. If you look up, of course, 1.25 in your table, it's going to give you 0.3944. And to get to the right, you simply take 0.5 and subtract out that 0.3944. And that's going to give you 0.1056. That would be the area to the right of that z-value. All righty. And then the last one on letter C, again, they want you to go between two z-values. This case is between 52 and 55. So again, let me draw my curve. And we've got 50 between 52 and 55. So again, you got to do them separately, just do them individually. So get two different z-values. We already know the z-value for 55 is z is equal to 1.25. For z-value that is 52, again, you take 52 minus 50, divide that by 4. Your z-value of course would be 0.5. So what you do is you got to look up these two z-values, and because these are both positive z-values, you would subtract. All right, so if you look up the z-value for 55 and look up that area, of course, you've seen this before, you're going to get an area, essentially that to the left is 0.3944. And then if you look up 52, the area, and 0.5, the area to the left of that is going to be 0.1915. So to get what's in between these two, you have to take the difference. So the difference is essentially right down here, and that's where they're coming up with that 0.2029. So if that makes any sense, you have to look up the z-values individually, but because in this case they're both positive, you have to subtract the two areas to get what's in between, which is what you're finding in this case. And again, if you looked up, let me go to the table, I'll show you where 0.5 is. That's when people oftentimes get confused with 0.5. Again, is right there. That's not 50%, that's a 0.5 z-value. All right, and I think that's it on this question. All right, let's check out number 6. Again, we're using the table again, we're finding areas, percents, areas, and so forth. So on this particular problem, we've got average refund is 2878, standard deviation is 520, and then we got to find the different percents for these different thresholds. So again, I'll label this. I'd say again, the mean or mu is 2878, where sigma is 520. So in the first one, you want to go above 3,500. So on that one, what you'd be doing is we know that the mean is 2878, that goes in the middle. We know that 3500 is somewhere above the mean, and they want more, so you're going to find to the right of that. So again, you take 3500 minus 2878, divide that by 520, and then that's going to give you your z-value. And again, try to take these out to 2 decimal places. In this case, that looks like it's right around 1.2. Put that right there. So again, at 1.2, if you go to your table, look up 1.2, you're going to get 0.3849. But at 1.2, your table is going to give you that area. So if my area there is 0.3849, and I want to go to the right of that, you'd have to take 0.5 minus 0.3849, and then that's going to give you 0.1151, and then just multiply that by 100, and that's what they want you to plug into there, because they want this one in percent forms. Okay. All right. So that was that one. On B, on this one, they want you to go between 2 z-values. So again, I would draw my curve. And again, we know the mean of 2878 is in the middle. And we want, it says, what percent of refunds are more than 3,500? So there's 3,500, but less than 4,000. So we're at these, that's not a very good curve picture, but they're basically saying they want to find this area that's above the mean. So again, we already got the z-value there, which is 1.2. You've got to get the z-value for 4,000. So again, you got 4,000 minus 2878, and then divide that by 520. And that's going to give us our z-value. So remember, once you get that, you got to look up each z-value individually. So the z-value for 4,000 looks like it's right at 2.16. So all you do is go to your z-table. If you look up 1.2, we know that that's 0.3849. So that's the area, again, that goes down to 0. If I look up the 4,000, which is 2.16, that's going to give me, it looks like 2.16. I'm looking right now, that's 0.4846. So if that's 0.4846, to get what's in between, you have to take the difference between these two. So you take 0.4846 and subtract out 0.3849. And of course, that would then give you your area, and which is going to be about 0.0997. They're showing you that right here. And then of course, you just multiply that by 100 to get 9.97%. All right. So that would be part B. And then part C, it looks like they want us to look between a negative and a positive z-value. But again, I like to draw the picture for you just to kind of help you, get that visual. So again, so we know our mean is 2878, and it says more than 2,400. So there's your 2,400, and again, less than 4,000. We already know our z-value for 4,000 is 2.16. So, and then I think, let me make page up here. Yeah, so then you got to get the z-value for 2,400. So you, again, take the 2,400, subtract out the 2878, divide that by 520. In this case, you're going to get a negative z-value. And on that one, your negative z-value is 0.92. Write that. All right. So we are looking between a z-value that's a negative 0.92 and a z-value that's right at 2.16. So if we look up there's several ways you can do this, but if you look up the 2.16, which I'll go and do, you look up the corresponding area for 2.16. I'm doing that right now. That's going to give me right at 0.4846. And so let me map that out. So between here and there's 0.4846. That would be that area. And then if I can just find 0.92, I'll look up the positive 0.92 in my table, and that's going to be right at 0.3212, it looks like. So in other words, let me just kind of draw the symmetry here. So if I looked up a positive 0.92 versus a negative 0.92, your table would give you from 0 to positive 0.92, which is the same as 0 to a negative 0.92. And if I look that up, it's 0.3212, and therefore that would be the same for each side. So essentially this area is 0.3212. All you have to do is add those two together, and you're going to get 0.8058. And then of course that would be your answer. And of course they show that to you right down here in terms of what you're doing to get that particular area. Alrighty, so that is problem 6. Let's check out problem 7. And on 7, they go backwards. They want you to use the table a little bit backwards here. So on this one, let's draw my curve, try to give you a visual of what they're asking for. So you've got mean is 50, and see sigma is 4. And determine the value which below 95% of the observations occur. So they're essentially saying is that 95% of all observations, that's the lower part, they're giving you the lower area of the curve. Is they want you to find the data point somewhere up here above. Somewhere up here at the top of the curve would represent a point in time where there's 95% of the values are below this number. So what you essentially have to do is you have to find a z value that corresponds to here. And once you find that, you can then figure out, once you find the z value, you can get the area. So remember, if I split this thing in half right here, we know that this half's got to be 50%. So therefore, this part has to be 45%. There's you get your 95 if I split this in half. So in this case, if I have an area that's equal to 0.45, I want to find that if I can find an estimate in the z table, that's approximately what value. So if I go to my z table, I'm going to show you, you're not going to find an exact number, but if you go to your z table, and I'm looking for 0.45, you don't find it. So 0.45, there's 0.4495, and there's 0.4505. So I can use either one of these numbers, and I believe your authors choose to use 1.65. Usually, you'd probably want to use 1.645. Usually when on my class, I give you a choice. I think they want you to use 1.645, but you'll notice 0.45 does not occur exactly in the table. So you just have to use an approximate. So in this case, you would just say, well, 0.45 is somewhere between these two areas right here. So use 1.645 as your z value. So once you do that, you just plug it into your equation. So if we know that x minus mu over sigma equals your z, so let me write it this way, z is equal to x minus mu over sigma. So if I do it that way, just plug it in. So 1.645 equals x, which is what we're trying to solve for, minus 50 over 4. You solve for x, and you're going to get right around, it looks like it's right around 56.58, which is what x is representing right there. And of course, they're showing you this. Let me show you this in the explanation. They're showing that calculation essentially right there. Alrighty, so sometimes you have to approximate the z. You don't always find an exact z value in these tables. All right, that's 7. Let's check out number 8. This is going to be the same type of problem. Let me map this one out. They want the lowest 3%. So essentially, here's my curve. They want the lowest 3%. And if I know my mean is 2100 and mu is 2100 and sigma is 250, they want the operating cost for the lowest 3%. So find the z value at 3%. So we know that the area to the right of 3% has to be what? Has to be 97%, just to kind of show you where they're going to get that. So if I reformulate this thing, and I'm looking at this curve from this standpoint, just showing you how you figure this out. So if we had wanted the top 3%, and I know the area to the left of that's 97%, if I cut this curve in half, because you got to use the half table, I know that 50% is to the left and 0.47 is to the right. And that's what so this is the area you're going to have to use in your table to find the corresponding z value. So if I go to my table, and that's essentially where they're getting that 0.47, because 0.5 and 0.47 adds up to that 0.97. So you always have to kind of cut the curve in half. So if I go to my z table and then look up 0.47, I'll show you how that you do that. So again, I'm looking for 0.47. And on this one, it does not look like you're going to find, you almost find an exact number. Hold on, let me get there. There we go. So 0.47, looking at it. There it is. All right. You can see that that's 0.4699 and then that's 0.4706. You don't find an exact number, but because that's probably about as close as you're going to get, just use 1.88 as your number. So that's basically an approximation. So in that case, go back. So if I know my z value is approximately 1.88, remember this is the lower curve, so you just have to put a minus in front of that. Go back to your formula, negative 1.88. Remember it's z is equal to x minus mu over sigma. So x minus, in this case, it's x minus 2100 divided by 250, cross multiply, add it. X is going to be equal to, it looks like, right around 1630. That would be your answer. All right. So that's my comments on number 8. Looks like we got 2 more. All right, number 9. So notice again, they give us the mean amount spent per year on reading and entertainment is 1994, and standard deviation is 450. It's normally distributed. So again, I'd map that out. I guess I write this every time just to remind you, because sometimes they throw so many different numbers at you, it's easy to forget. So the mu in this problem is going to be 1994, and sigma is going to be 450. And so then they have 3 individual questions, just like before. You have positive, negative z values, and you got to look these up. So the first one is you got to find the z value for 2500. So 2500 minus 1994 over 450. And remember, on this one, it looks like it's going to be a positive z value. We know that because we know the mean is 1994 right there. And then there's 2500. But remember, we want, this says spending more. So we want to find the area to the right. So once you get this z value, the z value for 2500 is 1.12. Right, this here z-route is 1.12. I go to my table. My table is going to give me, it looks like it's 0.3. I'm looking at my table right now. 1.12 is 0.3686. So your table is going to give you 0.3686 from 0 to this part. So just take 0.5, subtract out 0.3686, and that should give you your 0.1314. That would be your first one. Second one, they want you to go between 2,500 and 3,000. So again, I'll map out my picture here. So again, remember the mean is 1994. So we got two positive z-values. You got 2,500 and you've got 3,000. So they want you to find between these two data points. We already know the z-value for 2,500 is 1.12. Get the z-value for 3,000. Remember, it's going to be 3,000 minus your 1994. Divide that by 450. And you get those z-values. Remember, let's get that. So the z-value for 3,000 looks like it's 2.24. Write this here, just to remind you, 2.24. So all you do is you look up these two z-values individually, and then because they're both positive, you will subtract. So 1.12 is 0.3686, 2.24. Let me look that up real quick. Looks like it's 0.4875. And so you just take the difference between these two, the difference there should give you that 11.89. I think down below they show that in B, yeah, 0.4875. Let me clear that. They show that to you right here just so you see the calculation. But 0.4875 minus the 0.3686 gives you 0.1189. All right. And then the last one, it says spend less than 1,000. So last one on this one. So again, here's my curve. And I know my mean again, 1994, we're going to get a negative z-value because we know 1,000 is below the mean and they want that. So again, you take 1,000 minus 1994, divide that by 450. That's going to give us our negative z, which is about a negative 2.21. So if I look up 2.21 in my z table, we know that that's going to be right at 0.4864. And you'll have to subtract that from 0.5 because remember, when you go from a 0 up to a positive 2.21, that gives you from 0 to that point. We would want to the right of that, which is the same as to the left of negative. So once you look that up, you have to subtract that from 0.5, and then of course should give you your 1.36%. And then I believe they show you that at the bottom, which is right there. 0.5 minus the 0.4864. All right, and then one more. This was what, number 9. Let's check out number 10. And on this one, it's again, they give you an area. I'm just going to jump right to the last part. It's the upper 5%. So if I map out my curve, upper 5%, that's like saying 0.05. That means to the left is 0.95 area. So I have to split that in two. So, you know, if you do that, we've got 0.5 and then 0.45. Remember your curve, you know, cuts off right in the middle. So you're really trying to find the area that's 0.45, which remember you can't because that area is not exactly in there. And so I believe the number we used the last time was 1.645 as our z value. So this z value would be 1.645. So then at that point, you just have to plug it in